want to talk today about scalable and deployable data science with the Anaconda platform. And what we've learned in the past year and a half or 2 years, we've been working very closely with customers with Hadoop clusters and scientific workflows, distributed workflows. So I want to talk about a few different areas. I want to talk about the collaborative data science workflows and how those can come and really work across your data science team. I want to talk about scaling out with Anaconda and what we've learned over the years with working with Hadoop and PySpark and different distributed engines. I want to talk about productionizing data science projects and what that means to different organizations and what we've learned from that. And I also want to talk about data science deployment and something that's become a really big topic for us in the recent years. So when we talk about collaborative data science workflows, what we really mean are we have different roles within our organization. Business analysts, data scientists are really doing exploratory workflows. Along the way, as we go to the right, we have collaborative and publishing workflows. And then that deploy and operate. What does it mean to run a distributed job as one of these team members? And how can we use something like the Anaconda platform to help us do that? So something we've learned over the years is that rather than, when you think about scalable applications and deployable applications, you think about maybe huge monolithic applications that do everything. They do it all. And what we've learned is that data science teams often work layered and modular approaches. So what this means is during the exploratory phases, we might develop a data cleaning or application where we want to try different algorithms before we select one. And we might want to pass that to other members of our team. We all might want to be using the same data set instead of copying it over, or instead of copying boilerplate information from project to project. We want that in a reproducible, shareable way for data ingest, cleaning, computation, machine learning, and so on. So Anaconda is the first step in that, but I want to talk a little bit beyond that about how we can collaborate with the Anaconda platform. So by show of hands, how many people have used Anaconda with Hadoop or Spark? Excellent. So we often find the case with new distributed frameworks. We find that people, they discover Anaconda on their desktop, and there is some parallel functionality there, but eventually, whether you're using an HPC framework or you're using a Hadoop engine, we want to use the same libraries that we love on our laptop on a very large cluster. So 10 nodes, 100 nodes, 1,000 node cluster. How do we leverage those libraries? So here I'm showing a sort of a superset of some of the very common architectures we deploy to with the flexibility of Anaconda. So at the bottommost layer, you might have a bare metal or cloud-based cluster running on Amazon or Google Cloud Platform or Azure, or you might have bare metal machines. And you might have your data stored and your resource managed by different things. You might have HDFS and Yarn with Hadoop. You might be using SGE or Slurm or Torque or many of the other execution engines. So at the computation layer, you might be using something like PySpark or SparkR, like newer distributed runtimes. Or even at that point, we might be using Dask or distributed to do distributed array and data frame computations. Above that, so we start to see the blend of where Anaconda combines with these kind of distributed workflows. So we might be using pandas, numpy, scipy, and mapping those to the cluster. We might be using things like scipy, scikit-learn, NLTK, and we want to use those with Spark. So I want to talk about what we've learned over the years of doing that. At the application and visualization layer, of course, we want to do everything in a rich, interactive environment like Jupyter Notebook. This is very different than the batch jobs that we're used to submitting with Hadoop or Spark or other distributed frameworks. And we want to have visualizations, rich visualizations like Matplotlib, Seaborn, Bokeh that are interactive, all backed by this architecture. So I like to think of things in terms of the spectrum of parallelization. And we like to use this paradigm when customers or users approach us and say, I have this code that runs locally on a sample of the data. How do I scale it up to many terabytes or many petabytes of data? So if you think about the spectrum of parallelization, on the very left side, you have explicit control, things like multi-processing, multi-threading, MPI, 0MQ, messaging layers. And this is really the networking code that serves different types of application frameworks. And it's very fast, but it's very low level. And it's not something we want to have to write for every application that are data scientist applications. On the right side, we have high-level distributed SQL engines, things like Hive, Pig, and Impala. Very, very powerful, in-memory, fast, but they're, by nature of their high-level APIs, are restrictive. So they don't always do exactly what we need. We end up having to rewrite an application from scratch. In the middle, I have two important blocks, and this is really where Anaconda focuses on the flexibility of filling that gap to say we have something like Dask, where we have data frames on our local machine, or we have arrays on our local machine, or some collection of data files. And we want to run that on our machine, and with the same code, we want to deploy and use that on a cluster, whether that's Hadoop or not. We want to provide that flexibility so it does 80% of the work, so you don't have to reinvent that boilerplate each time. Something like Hadoop and Spark provide alternate engines to do that. So Spark has a very high-level API. It's very nice for graph computations, for machine learning. There's MLlib. And the great news is you don't have to choose between one or the other. Anaconda works in these environments and fills that gap. So scaling out with Anaconda and Spark, we've learned that a good portion of our customers, maybe 3/4 of our customers, use Anaconda and Anaconda Enterprise as a gateway to using PySpark. And this is great news because, again, it means that they don't want to be thrown into this new environment with new APIs. They want to use scikit-learn, scikit-image, pandas, NumPy, things from Anaconda in the context of their enterprise computations and parallel computations. So when you use Anaconda with Spark, it's extensible. So you're using the libraries you already know, the APIs you already know, accessing the data in ways that you're used to. It's integrated. So if you have a Kerberized or a cluster that's secured with Kerberos within HDFS and Yarn, it just works. It's secure. It's scalable. So if you have NumPy pandas code that's using data frames and arrays, it's very easy to map that with PySpark. That's a very common use case to map. Maybe you're doing Monte Carlo simulation, and you want to map NumPy pandas jobs to a 1,000-node cluster. That's very straightforward to do with Anaconda without having to rewrite things in other APIs. And it's very seamless. So it works right alongside Cloudera, Hortonworks, Pivotal, MapR, IBM distributions, and other Hadoop distributions. So basically, what we do here is we take care of the installation and management of Python and R packages and environments. So in a Hadoop cluster, it's very easy to have Anaconda installed alongside Python 2, Python 3, R environments. We take care of all that, so you don't have to think about that. You just import the libraries you already know when you need them. I also mentioned Dask here. So Dask is an alternate parallel Python computing library. It's familiar, fast. It's built for the Anaconda and PyData ecosystems. So the Dask developers work very closely with scikit-learn, scikit-image, pandas developers to take those same concepts and bring them up to a scalable cluster. So it's very easy to run them with all of the cores on your laptop or all of the nodes in your cluster. Other ways to integrate with Anaconda. So I mentioned before that we get asked a lot, should we use Anaconda or should we use X? Should we use X Hadoop distribution or X data format? The answer is always use both, right? So Anaconda integrates with Spark in ways that I mentioned. So PySpark and SparkR, you can run those kinds of jobs with libraries from Anaconda. It integrates with Yarn, with HDFS, Hive, Impala, and many of the other Hadoop. There are native connectors in Python that make it very easy, which means you don't have to switch between applications. You just use Anaconda and integrate it with the rest of your data science workflow. Things like Dask, there's an ecosystem around Dask. So Dask distributed, things like NIT let you interact with Yarn. You can easily spin up clusters on EC2 with workers. You can read and write to data, to HDFS data stores, including in the Parquet data format, all from Python and all from Anaconda. We have customers running environments on bare metal as well as cloud, including Amazon Web Services, Microsoft Azure, Google Cloud Platform. So it's very flexible. There's not one architecture that we're going to prescribe. It looks more like what I showed at the beginning, sort of a superset of environments we can run in. Streaming analytics, right? Very popular. We have customers using things like Apache Storm, Spark Streaming, Kafka, also Elasticsearch, Logstash. Python connectors for all of those. They can all be used in the context of Anaconda with the kind of stack that I showed earlier. And our technology partners here are key. We have two-way relationships with, so we partnered with Cloudera, partnered with Hortonworks, partnered with IBM, H2O, Docker, and more to make sure that we're leveraging best practices from both worlds so that we can leverage Anaconda from whatever your setup is in the enterprise. So when we think about scaling out with Anaconda, we want a place where our data science team can work on one integrated platform and leverage something like a Hadoop cluster to do the heavy lifting with all of the libraries from Anaconda that we're familiar with. So what I want to describe is more of an ecosystem and philosophy of Anaconda and why you can use it in a flexible way for many of those types of environments on one consistent entry point or platform. So scaling out with Anaconda, one of our platform components is Anaconda Scale, and what that really means is it maps to customers' environments. So some customers are using it with Cloudera, some are using it with Hortonworks, some are using it without Hadoop at all, but they're making sure that Anaconda exists on all of the cluster nodes when they need it, and we've learned over the years the best ways to make that happen. So with Anaconda Scale, without Anaconda Scale, what you're stuck with is essentially installing system libraries, Python, R, all the dependencies, making sure the compiler's there not only on the head node, but on each one of the compute nodes. It's a very manual process. With Anaconda Scale, we have many different approaches. So we have things like the ability to generate custom parcels for Cloudera clusters. Very soon, we'll have the ability to do the same for Hortonworks clusters natively with Apache and Bari. We have the ability to deploy right along with Spark or Yarn. So you can encapsulate the environment you're working in, ship that to all of your nodes and have it working there. And this is a very powerful way, again, to make sure that your environments are replicated on the cluster without worrying about whether those environments are consistent or not and in a secure way. So we have lots of interesting use cases that come from our customers and users, whether it's financial or engineering or government or oil and gas, energy. So here are some of the common example use cases. Maybe you can relate with some of these, and we can talk about how to get started with these. But one of them is analyzing text, tabular, or array data using Dask. So people, like I mentioned before, they want to run pandas data frames, NumPy arrays, and they want to work with many different formats. Maybe they even have custom workflows, which I talk about later. But this is something where they're able to run on their local machine, use the same code, and run on the cluster, whether this is a Hadoop cluster or not. And with Anaconda Scale, we make this very easy, both the library management and the runtime management, to just have this work when you expect it. Another one that's very common is distributed natural language processing with Spark. So in this case, we want to explore data in memory, but we also want to use libraries from Anaconda like NLTK and Spacey and other things that are available. So we want to be able to combine the best of both worlds and have Spark the compute engine using natural language processing functionality. And this is very easy to do, very common. In fact, I'll show that on the next slide. Other workflows that are popular are distributed machine learning workflows. And the combinations here are endless. So people are doing all kinds of interesting things with Dask, Spark, H2O, TensorFlow. I've heard a lot of those use cases here at AnacondaCON, and some of our demo kiosks are showing exactly that with TensorFlow and Dask, and so on. So this allows you to do, you can basically, machine learning libraries like TensorFlow have dependencies in C++. We don't want to worry about that tool chain, so you conda install it, use Anaconda Scale, and it's there when you need it. It also allows you to work interactively in a notebook. So a lot of the machine learning and pipelining tools or batch processing methods are very one way, so you sort of run it and forget about it, come back later. Working in a notebook allows you to interact in real time with your pipeline and construct your pipeline and get real-time feedback. So it just shortens that development cycle on your data science team. Finally, custom code and workflows. I mentioned before the spectrum of parallelization, and with something like Dask, you can work with custom data formats that it doesn't natively support yet. It's very easy to take your existing complex pipeline, parallelize that, wrap that, and having that run on a Spark cluster. All very flexible. So here's a couple of use cases shown in detail. So this is the distributed natural language processing with PySpark and Anaconda. So here, what we're doing is we are running Anaconda, in this case, Anaconda Enterprise with the collaborative notebooks, and we're actually connecting to a Spark cluster. And so we instantiate the Spark context, and we can do general things in PySpark, like read data from HDFS, it's in memory. The really interesting part is here, when we import NLTK, and we do things on Anaconda, just like we do on our local machine, except this is being shipped to our 100-node Spark cluster, and it just works. So no rewriting, no remapping things, it just works with Anaconda. And once we've done the heavy lifting on the cluster, we can actually bring that back to this local node and do the things we're used to doing. So we can work with pandas, we can work with bokeh. All the heavy lifting's been done. I can save this notebook and either deploy a static version or dynamic version of this notebook that's actually accessing that data in real time. Distributed data frames, another common use case. So here we have CSV data stored inside of HDFS. And with Dask distributed, we have a cluster of Python workers ready to accept jobs. So here we're reading in this case, it's 20 gigs of data on disk and about 60 gigs in RAM. And we're reading that in. So we're reading in with pure Python. We're not using the JVM at any point with Dask and distributed. So we're reading data directly into our Python workers from HDFS. Recently, we added support for to read Parquet data, which is a compressed columnar store. So you can do all the things you're used to doing with Hadoop and Spark, all from a complete Python stack. So once we've loaded the data in memory, it's a very familiar experience. So you do data frame computations, filters, group bys. We can actually see very detailed progress bars, very interactive, very real time of how that's executing on the cluster. And finally, you end up with a familiar bokeh plot. This particular one shows the tip fraction of New York City taxis over time. And the last thing I'll show here is a lot of interesting work. This is happening so quickly that even this from a few weeks ago is out of date. We have a very interactive way to look at how our distributed Python computations are happening on the cluster. It's a great way to profile distributed jobs, which is not always the easiest thing to do. It's a great way to look at where is our time being spent, what's happening to the memory and the CPU on our cluster. So Anaconda really gives you a gateway to look at all of this without switching context between different tool sets. It just gives you one entry point to do all of that. Productionizing data science projects. So this is a particularly big topic for us, and it's interesting that different enterprises have different definitions and workflows of this. What it really means for the end user is they want to be able to take data and they want to, in their machine learning or their data science workflow, they want to be able to take different assets of that and either deploy them or make them available to other members of their data science team or to external users and customers. So what this means is I have code in a script or a notebook, and I want to take some portion of it and make that an interactive report. Or I want to take another portion of it and deploy that as a predictive model with a REST API so other developers can build on top of that. So it's that modular workflow that I talked about before, and this all fits within the paradigm of Anaconda because it's not a monolithic stack, it's very piecemeal, and that I can represent these at different stages in my data science workflow. So productionizing data science projects, these are some of the top, most popular topics that we've helped customers go through as they bring their data science workflows into the Anaconda ecosystem. So provisioning compute resources, managing dependencies and environments and making those available on a cluster, sharing compute resources, security is a big one. Once I've productionized an application, how do I actually secure all of the end-to-end communications? How do I make sure that it has access control and authorization when I need it? So these are some of the big topics, and I want to talk about now how that relates to the deployment context. So model deployment or project deployment. Again, by a show of hands, how many folks have deployed a model and have been through that end-to-end process, right? So we've talked a lot, about a quarter or a third of the audience, so we've talked a lot in the past few years about how to develop rich applications, how to develop dashboards, and the biggest question is, now that I've developed something in enterprise notebooks or repository, how do I deploy that to the rest of my organization? How do I make it usable outside of just of my laptop with a very long configuration setup? So what we've learned is throughout this collaborative data science workflow, we talk about review, design, and building stages. What I want to talk about now are specific production assets or projects and how we might validate those and ultimately deploy them. So I'll talk about that now for a few specific use cases. So for notebooks, because notebooks contain visualizations and code and narrative, they're a really nice way to work and iterate and prototype things very rapidly. And when we say productionizing notebooks or deploying notebooks, we want to share them, right? We want to share them with end users in different ways. So maybe a static notebook is okay for certain applications. We can post it on GitHub. We can put it in Anaconda repository on our on-premise repository. And that's a static rendering of a notebook. It might have an interactive bokeh component, but for the most part, the analysis is static. So those are some ways to deploy that. For deploying live notebooks, some of the functionality we're announcing this week is data science deployment of live assets. So just following this session at 4 o'clock, we'll be talking about that and showing a demonstration of what it means to deploy a live notebook that your end users can run, get the latest data, download data, it has secure credentials. So we're really extending that piece from static notebooks to live notebooks. For dashboards, this is a very interesting space, especially for our customers and users that are using Jupyter notebooks. There's a very interesting project in the very active Jupyter ecosystem called Jupyter Dashboards. It's an incubating project, and here I'm showing on the left how you can take a notebook, you can add some additional extensions and server-side components, and you basically have the ability to take your notebook cells and drag and drop them around and lay them out interactively in a dashboard, and then with one click, you deploy them as a dashboard to a Jupyter Dashboard server. So because Continuum works with many different open source and different partnerships. We're very close to the Jupyter ecosystem. We have a number of folks that are working very close to this ecosystem. So for us, this is just a reach away to say, yep, Anaconda, we can leverage that in this environment. You could have bokeh plots, Dask, all of the things we're talking about, all included in this type of layout. So the idea of having a running dashboard that people can interact with IPython widgets interactively with a live Python process is very exciting for us. And again, we're extending on this in the future, and you'll see more of that in the roadmap session later today. Interactive applications. This is an area where you've probably seen many webinars and many blog posts from us about what we've learned with customers about an interactive application framework. So something like bokeh is very powerful. It allows customers to develop things like this. So on the left side is a market data example. So I have a couple of ticker symbols, and what this is doing, this is pulling data live. It's a live visualization server, live Python process. So it's pulling data as I make selections with the widgets. On the right side, I have things like linked histograms. These are great not only for end users, but for intermediate stages of my data science team's workflow. So for interactive applications, typically what you're doing is you are to productionize this and deploy this means you are installing web frameworks, and you're kind of wrapping these with other things. So you'll need to install system libraries and forward ports, and if you want this to be really scalable, you'll need a reverse proxy and load balancer. So we've learned a lot about this process and about how to make that repeatable. And again, a big theme of this week and what we're kicking off for the next generation of Anaconda Enterprise is how do we encapsulate this so that next year when I ask, have you deployed an application, everyone raises their hand and says yes, thanks to the Anaconda platform, right? We want to capture that and make it easy for everyone to do. Another common use case is models with REST APIs, right? So all about this modular workflow. So we have different stages in an example machine learning pipeline. We load data, we clean it, we do anomaly detection, regression, clustering. Why not expose each one of those steps to make sure that everyone on our data science team is able to interact with and select the best process for each one of those? Or what if we're actually using it for different data sets and we want to actually leave some of those options open and not wrap this up into one application? So when we think about models with REST APIs, what we're saying is that we can actually deploy intermediate applications that represent any layer in this process. So we can take, after the second layer, we've cleaned the data, we can then make a model with a REST API and serve that out to the rest of our data science team so they don't have to copy and paste that same code throughout applications. We just have one source of truth for that data. And then maybe later we want to do anomaly detection, but we're not exactly sure on the hyperparameters we want to use. So we might have an interactive application where data scientists, data engineers work together to select and iterate on the best selection. So this really means layered approach, modular approach, and composability of our data science workflow. So to conclude sort of the Anaconda platform and how Anaconda Enterprise relate to all this. So Anaconda is our core and allows us to work with machine learning, with analytics, with visualization. Anaconda Enterprise builds on top of that and gives us scaled up analytics. It lets us develop and deploy the same code, whether we're using Spark or Dask or Yarn or HDFS, whatever our architecture looks like. We're able to take that code and deploy it to the cluster so you don't have to, which gets to the second point, do environment management by hand. Instead of spending time making sure that Python versions match and library versions match, we take care of that for you across your cluster. And again, like I said, we work very actively with enterprise Hadoop distributions to make sure that you don't have to choose and you don't have to context switch between them. You can all work with Anaconda as your entry point. Collaboration is big for us, obviously. We want everyone across the data science team using version notebooks and projects, and we want to take care of that for you so you can get back to the data science and back to the analysis. And Hadoop integration. So we have strong support for Hadoop, Spark, other distributed workflows, and we work alongside Cloudera, Hortonworks, IBM Pivotal, and other distributions, MapR. So in conclusion, you can find more information about Anaconda Enterprise subscriptions. You can look at Anaconda Scale to learn about the different ways that we map to whatever your deployment scenario might be, whether it's a user land deployment with Spark and Yarn or a system-wide deployment with something like the Cloudera parcels or the soon-to-be Hortonworks functionality. There's a blog post that we put out last week on our developer blog that is a very comprehensive overview of the productionization and deployment topics that I covered today. And what this is really all of the details we learned over the years and what kinds of tools you would use today for the dozen or 100 steps that you have to do for deployment. And what this is leading up to is a comprehensive review of what we're going to announce and provide as part of Anaconda Enterprise so that we close the loop, so that we have repository, enterprise notebooks, cluster workflows, and deployment. So with that, we have an end-to-end workflow that you can collaborate with in your data science team. Thanks a lot, and join us. I'm over at the demo booth if you have any more questions about distributed workflows or Anaconda Enterprise Next Generation. And for a follow-up, please join us in our roadmap session. I'll be showing a lot more details about how we've taken all of this, productionized it, and made it available to Anaconda and Anaconda Enterprise users. Thanks a lot.